ecosystem. Okay. Um, so on the Hadoop ecosystem, we have some packages, we have some applications. So you're welcome, Eric. So on the Hadoop ecosystem, we have some applications that forms the ecosystem. So Hadoop is like it's like the motherboard, and we have different applications that comes in place, different tasks, and it's always good for us to understand what each of them are coming to do. So we talk about from the first level is the HDFS, which is the Hadoop distributed file system, which is like the first layer of the ecosystem. So is the HDFS is like the platform where every other component relies on. So the HDFS is the guy that enables distributed file system. So without the HDFS, there's nothing Hadoop will be sitting on. Yesterday we talked about the three main components, talking about HDFS, MapReduce, and YARN. So HDFS is like the platform whereby enables the distributed computing. So if HDFS is not there, there's nothing MapReduce will be working on, and there's nothing YARN working on. And the next layer is we have the YARN and the MapReduce, and that is distributing the process. So though it's possible you have guys that can work for you, but you might not have what they call the leadership role. So it's possible when one goes to office, they said, okay, so you have the ability to control 5 guys, and you have 5 guys reporting to you, but the person can just have the knowledge, and they might be available, but not having the capacity to instruct them and assign tasks to them. So we have YARN and MapReduce in that function. Though we have our HDFS having the ability to distribute file, yes, it doesn't end there. There are guys job of instructing and coordinating the work of those guys. Okay, see, I know you're available, so you do this, you do that, and you do task 1, task 2, and when you guys are done, compile your work and send it back to me. So YARN and MapReduce are there for distributing the work process, and we have OZ, we have Peak for scripting, OZ for the workflow, we have Peak for scripting, and we have Cohort for machine learning, and we have R connector for the statistics, and we have I for SQL query, and we have the Ambry at the front end, and also we have Flip, we have Zookeeper, we have Scoop. So we are going to look at these guys one after the other. It is always interesting. So I remember the first question when I was having my first attempt on like that was the test questions, maybe after the 40 days of training on the page. One of the questions I saw was one of the ecosystem of Hadoop. So it is very, 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 very important that we understand what all these guys does, what is the role of each of them, and we are going to go into we are going to see their role as we move on, and we are going to see what they do as we move on. So so that's the level 1. So those are the ecosystem. Before the end of this session, we are going to have a deep dive on what does Peak does, what Scoop, Zookeeper, FluentOZ, HBase, I, what does it do, what are they doing? So we're going to see into that. So and the HDFX architecture. So the HDFX architecture, like what we said yesterday, there's always keep in mind that there's always something called the name node. So and we also keep in mind that there's something that happens. There's something that happens Uh, so when you load a file into the system, there's always a breakdown. When we read the first paragraph of page 61, it says HDFS address the challenges by breaking files into a collection of smaller blocks, and these blocks are distributed among the data node in the HDFS cluster and are managed by the name node. The block size are configurable and are usually 125 megabytes. So let's see, that's one of the interesting thing of about HDFS and the Hadoop architect, the HDFS architecture. So when you send a file, and the size of the file is like 1 gig. If it's like 1 gig file now, it's going to distribute, it's going to break that 1 gig file to bits, to like smaller bits. So the essence of this is that so that each processes can work independently on each of the bits. So after working on each of the bits, they collect the result and send it. So if so they don't, just imagine when you're working with, when you are having a process and that process is working on the entire 1 gig. So if the entire 1 gig process will be heavy compared to when the process is working on 128 MB. So the distributed file system is going to distribute them in chunks and say, okay, like my data node 1, take this 125 MB, data node 2, take this 125 MB. So but one thing is, let's assume that the 125, the 1 gig is, if we divide 120 like 128 MB divided by 1 gig divided by 128 MB, so we are going to have like, that's 1 2, so we are going to have like 8 chunks. So now those 8 chunks will be distributed randomly to all the data node, and in a way that um there's replication. So on data node 1, so data node 1 can have, so you do know we have 8 chunks, right? 8 smaller chunks. Data node 1 can have chunk 1, 4 and 7, for instance, and data node 2 can have chunk 1, 6 and 8. Data node 3 can have chunk 6, 7 and 2. So they have it randomly, but one thing that is very sure is that each chunk is replicated at least on 3 data nodes. So the essence of that is that in case if one of the data nodes goes down, the other data node that is active will have a replica or a copy of the missing chunk, or maybe on the failed instances, and it picks it up from there and continue the work. So that is that. And another thing we keep in mind is that when the process is running, so I remember when we were having a class, there was a question that was like, then how will the data node, for instance now, if chunk 1 is present in data node 1 and chunk 1 is present in data node 2 and chunk 1 is also present in data node 3, how will the system understand that which hope all the data node will not be running the same processes on data node, like all of them still running analyzing chunk 1? No. What the name node does and what the resource manager will do is that it's going to assign that, see, data node 1 just work on chunk 1, data node 2 just work on chunk 3, data node 3 just work on chunk 2. So it is a well coordinated environment whereby they don't do the same thing. They are well coordinated, they know what to do per time, and when they are done, they gather the result, and that's the reducing part, and they produce the result. So we have, like we said, we have the name node, and we have the community server, that's like data node. Those are the guys. So in real time, or let's say in a physical environment, we call them slave. That's the slave environment. It's just like a backup to get the work done. So HDFS follows a master-slave architecture, where in HDFS cluster includes a name node, that's the master, and multiple data nodes. So these are things. These are the basic architecture, which I feel we are just trying to remind ourselves about it. We've explained what we call the name node. That's the guy that does the bulk of the work, and it's a file system. A file system namespace is a collection of okay. So it's just like the guy that controls the entire process, and it keeps the log. It keeps the track of every job that is done. So that's that about the name node and the data node. We talk about. I said something yesterday. There's always an out-bit connection, whereby when a data node is down, the name node gets a notification, because there's as soon as the data node is up, there's an heartbeat connection that send a message to the name node to notify the name node that, see, I'm still available. So anytime the heartbeat fails, um, the name node understand that the server is not available, the data node is not available, and re-strategize the distribution of the work. Okay, so that's that, and we can set a figure 3 on page 63. So data safety. So like what I think I've explained some things about the data block, whereby data block are replicated on different servers. The transaction log enables enables the system to know that, okay, which data node is performing a particular transactions, and we are very sure that our data is secure. So we keep in mind this thing, the function of our block server, and this is on page 64. It says the block server stores the data block in the local file system of the server. Each DFA is available on many different operating systems and behaves similarly. Store the metadata of the block in the local file system, perform periodic validation of checksum, send regular reports to the name node about what blocks are available on the file operation. So now the block server is just like what the block server does, and that is like on the data node, what really happens, what are the processes that happen, and it's just about coordinating the entire data flow, trying to understand what are the capacity, what can I do, just as if you have like the example we gave earlier, that a a manager has some guys that are reporting to him, and each of them is saying, see, Oga, these are things I can do. Okay, I still have this task on my table. I have ability to do this. I have this file. I have access to this. So they get the name node get a feedback, understanding what the data node can do. So there's a synchronization that happens between the name node and the data node for easy understanding, for an easy management of all the data nodes. So we also need to understand what they call the pipeline. So the pipeline is a connection between multiple data nodes. So what connects data nodes together is what we call the pipeline. That's where the information moves from. We have all the in and house operation. So that's that. So and another thing. So if we go through it, we see few things we mentioned about the replica, and how it sends additional replica random location to, okay, like we said it sent additional replica to random location in local or remote cluster. So and that's just summary of what we said earlier, that the chunk of data block are randomly sent to different data to different locations to avoid loss of data. So also keep in mind the HDFS Federation. So HDFS Federation is an architecture whereby you have what they call a the second master. Most of the time, on the first Hadoop system, HDFS Hadoop 1.0, we only have one master, and we don't have the secondary master. So what this means is that just as if you go to a place of work and you don't have assistant manager, you only have the manager. So when the manager falls sick, there's nobody to pick up from where he stopped. So in the federation, in the HDFS federation, we have ability to have the secondary guy to be on standby. So anytime the main name node fails, the secondary name node picks it up, and what that guy does is still the work of coordination. So it's still like um, everything the node is doing, like the coordination is doing, the data allocation, every assignment the name node is doing. As soon as the name node, maybe the primary name node fails, the secondary name node picks it up from where it stops, because the log of the file, one thing is that they will share the same memory, whereby the log of the file just picks from where it stops and say, okay, just as if when somebody wants to, when if someone is going on leave and say, please, you need to have a handover document. Yes, so the primary name will hand over the log file to the primary name node, hand over the log file to the secondary name node, and the secondary name node picks it up from there and continue as if nothing happens. So the advantage is that failure of one name node does not affect availability of other namespace managed by the name node. However, the block pool storage is not partitioned, and so that the data node register with one name node in the cluster and store blocks for the multiple blocks pool. I think I've explained that. So so that is that. So that is that about the HDFS Federation, and it is available, highly available. So like we used to remind ourselves in our exam, we'll be required to demonstrate our understanding of how data is stored on HDFS. So and so just need to understand how data stores in replica. Okay, there's data stores in replica, at least 3 replica on different data nodes, randomly distributed, and the block of data is divided into smaller chunks of maximum of 128 MB or 256 MB. That's fine. So in our knowledge check, we are asked what's the function of data node and name node. So once we are done with section 5, we come from section 1 and we answer all our knowledge check, so that all of us can keep in mind, and we can be sure that we are all carried along and we are getting ready for the exam. So so that's that. So processing data with MapReduce. Yeah, processing data with MapReduce. So yesterday I said something about MapReduce is just that guy that does something called the mapping and the reducing. So just mapping and reducing. So how does this work? How does MapReduce work? So a MapReduce worker processes data. So how does a MapReduce work? So when you pass an operation, when you pass an instruction to say get this thing done for me, the mapper will send that message to all the data nodes. I think we have an image. I think there was a figure yesterday that gave us an example of what happens? Okay, that's close to what we have on page 48. So what happens is that it's when an instruction is passed across and say, okay, we have a specific task to be done. What it does is, as soon as the instruction is passed, it takes that instruction and map it to different name nodes. So it says, okay, name node 1, I want you to do this for me. Well, name node 1, I want you to, for instance, now let's give a physical example. Let's say we have an Excel file, or we have a text document, and we have words inside them, and we need to count the number of words inside the document. Maybe the document contains like 500 words, and we need to count how many words and what is the frequency of each word in that document. So keeping in mind that how the system works is that that document will be broken down to chunks. It's possible that the first 50 words, or maybe the first 30 line, is in say data node 1. 31 to 60 lines is in data node 2, and 61 to 90 lines is in data node 3. So what MapReduce does is, once you now tell the system, count the number of words in the entire document, so it gives that instruction to each of the data nodes. So each of the data nodes now come, how many words, for instance, we have maybe a particular name, how many words, and what is the frequency of the word. It does the counting. So after doing the counting of each of the words, it sends that result back to the reducing function. The reducing function collates from every guy and aggregates it. So maybe the word DASCA appeared in say data node 1, and also appeared in data node 2, and data node 2, and also appeared in data node 3. So what we're going to do is that by the time it is reducing, how many times does it appear in data node 1? Sum it to what is a number of appearance in data node 2 and number of appearance in data node 3. So at the end of the day, the reduce function will aggregate it in sum and produce the result. So we have the mapping that maps the same instructions across different data nodes and reduce it to what is expected to be given, like what should we give, and that is the value that is expected. Maybe the function is just to do a count, and you get a count as a reduced function. So it's always in terms of distribution. So there are some strengths and weaknesses. MapReduce can handle some issues better than relational database. Such tasks include things like things such as person tests, crushing through web blogs, reading in a huge raw data set, data sources. So those are one of the advantages of MapReduce. It can read the big data channels, like analyzing digital footprints like web blogs from different clients, and MapReduce is used like an extract, load, and transform. So MapReduce itself can perform the entire process of extracting, transform, and loading. So it can load back to any type of text format, either back to a database or to a text or to any format that will be provisioned for it to run. So, and also we have some challenges. One thing is MapReduce is not a data block, so it's like security, indexing query. So all those things are yeah. So it lacks some basic things like indexing. So the only time we can secure our data is when they are inside our database. Then we can be sure that they are secure and we can work fine with them. So MapReduce comes with the responsibility of defining exactly what type of data is created in every process. Yes, MapReduce consider every job as entity itself. So MapReduce doesn't keep a lot of things in memory, like relational databases does. Every job is an entity on its own. So that's one of the challenges of MapReduce. So and also moving to what we call the yet another resource negotiator. So we said something was said here. Said all the required system information is stored on a resource container. That's the last paragraph. It contains details CPU, this network. So let me just give a summary. We have the material to read. The resource negotiator is that guy that tells the system what is the capacity of each of the resources, and if resources is needed, how do they allocate resources? So that is what that guy does. Yeah, he does the resource negotiator. If a particular name node, he checks the capacity of a particular name node. If that name node should be assigned more jobs, or if the name node has the capacity to do more things, and the resource negotiator understand and send additional work to it. And also on the other hand, resource negotiator also give resources. For instance, now on a parallel computing net architecture, if you understand that a particular name node needs more resources to perform a particular task, corresponding or needed memory space is assigned to that name node for efficient running of the assigned task. So that's something about the overall understanding about our resource negotiator. So and we have some characteristics of HBase. So now what is HBase? HBase is like is the relational database form of Hadoop. It's the guy that stores things in almost like a relational. Again, it gives us a relational structure of what a structured way, like what a relational database, a standard relational database will do. You see, as HBase is a columnar database, it enables all data to be stored into tables with rows and columns, similar to that of relational database. So HBase in general, it gives us a feel of a relational database. One important difference between HBase table and relational database table is versioning. Versioning. Oh, I would like to explain this versioning. Just this doesn't just change on Hadoop. Most of the time, there was a time we got based on this certification that on each base you don't delete anything, you don't truncate, you don't drop. So when you issue a command say drop, what the system does is that it only switch the version, or when you say update, it doesn't remove what was there before. Wow. Okay, somebody said I can't hear you. Call me. Oh, Samaira. Okay. Please, Olufemi, please, can you hear me? I want to be sure it's not from my head. Titilayo, please, can you hear me? Hello? Can you hear me?
Yes, I said it's breaking at some point. Can you hear me now?
I can hear you.
Yes, I said it's breaking at some point, and I also want to find out, do you have all this explanation on the slide that you can share with us? It's beginning to look very abstract and very confusing.
Wow.
Yes, so maybe if you have a slide that we can also be looking at the same time as you're speaking, it might help somebody like Misha, because I'm really not into so much talking without seeing what is being said.
Okay. 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 Thanks for the feedback. Thank you for the feedback. Okay, let me do something. Though what I'm taking the class through is just what we have on our material. So, but let me try log into one of my environments. Let's go.
Hello, hello, can you hear me?
Yeah, I can hear you.
Hello. Yeah, not necessary this meeting. Probably you can improve in the next meeting. You can go on with the meeting. I think we are enjoying it for now.
Okay.
Can you hear me?
I
Yes,
can
we are
hear
enjoying
you.
the. Yes, please go ahead with the meeting, please.
Okay. So thank you, Olufemi. Um, so for Titilayo, um, I'm coming. I just want to try do something so that we can all one minute. I just want to get some. Okay, fine. So I'm going to share my screen now. I'm going to share my screen now. Let me see. Okay, can we see my screen?
Yes, so I can see your screen for my end.
Okay, fine, fine. So, so Titilayo, so this is like, this is a slide that we can also walk through. So these slides are available on our data science school. So that's what I will be. I think moving forward, will be working with the slide so that as I'm explaining, you can also see summary of what we're expected to know. Okay, so that's fine. So on storing data with HBase, that's where we are, and something about HBase, like I said, HBase is a columnar database which enables data to be stored into tables. So what is columnar database are like? Columnar database is like, you don't have it in rows like a relational database, whereby you have transactions. So instead of having transactions, there are paired column and a lot of columns. It's always the best way of querying tables. So if even in relational database, when we want to do some advanced analytics, we need to convert our transaction table to what they call a columnar database so that we can easily use it for analytics. So this is what the HBase architecture understands, that from onset they set it as a columnar database. And another thing is about the HBase is it works with versioning. So the versioning tracks changes in the cell and make it possible to retrieve at any version. So when you update a table in relational database, it's just as if you erase and you rewrite. But in HBase, when you say update from 1 to 2, it doesn't change it. It only tell you, okay, now the most recent one is 2. So if tomorrow comes and feel like, see, I want to go back to what I did before, I want to go back to my version, we can have multiple versions. If you tell the system, say I want to go back to my version 2, or let's say version 1, it goes back to what you claim you updated. So it gives room to versioning, and things doesn't just changes, you don't delete. So even there was a time I got to understand that you don't even truncate. Even when you say, okay, truncate a particular table, it takes time. It's only version. I'll say, see, I'll still keep it for you for rollback. You might come tomorrow and say, see, I need this record back. So we see that in relational databases whereby you drop a table, and after some days you can still roll back those tables or flashback those tables. And in HDFS we do what they call the versioning. Hello? Okay. Okay. So another thing is the map is indexed by a new key, column key, and timestamp. So the versioning is a function of timestamp. At what time? What is so to every record that you hold, you have the row key, the column key. The row key can be like the customer ID. The column key is like the variable name, and the timestamp is for the versioning. So it's like a three-dimensional. Most of the time, I view it as a three-dimensional plane. So it's a three. To me, I see HBase as a three-dimensional plane, and whereby you have the row, column, and the timestamp for versioning. So you can go back to previous version, but what is mostly shown is the most recent version, and that is what they call the timestamp version. So one important difference between HBase table and RDBMS table is versioning, which we said earlier. And implementation of HBase are highly scalable. So it's highly scalable. When you want to scale, you can scale HBase well enough. Highly scalable, sparse, distributed, persistent, multi-dimensional, like what I said the other time, 3D. So we can have multi-dimension. So it's always interesting to have a mental picture of what HBase really holds. So we have important characteristics like consistency, sharding, high availability, and client API. So it's consistent sharding, like HBase offer transparent automatic splitting. So sharding is when something comes in split. Distribution of the content, because data is distributed by supporting file system, so you can shard it into different bits and it just flows. So when the first one comes, the second one follow. High availability, and you can access them through Java API, and that's interesting. Whereby you can third-party application can easily consume HBase file. So so querying database with HBase with Hive. Querying database with Hive. Hive is not designed for quick response or query. So one thing about Hive is it's not like the other relational database. I said I'm trying to see how to bring it. From what we have in the book, he said Hive is a batch-oriented data warehousing layer built on the core element of Hadoop. So for data warehousing, when we have our data set well structured and well organized, so we talk about Hive. So we talk about HBase for a relational database structure. But what we are talking about Hive is like a data warehousing layer that helps us for easy, though it is not designed for quick response to query. No, it's not designed for quick response to query like HBase will do, but it still gives us the most efficient means of accessing big data. It provides users who know SQL with a simple SQL-like implementation with what we call HiveQL. So HiveQL is like the normal SQL and very similar to the structured query language. So with this, you can with Hive, we can make use of our normal SQL programming skill. So because Hive has what they call, we have tables in Hive. Here we have the Hive table are the same as relational database tables consisting of rows and columns. So don't let us forget, we talk about this guy HBase. HBase is a columnar, so it's not like relational database. But Hive is more like a data warehousing that gives us stuff into rows and columns like that of relational database. And we have partitioning. A Hive table can support one or more partitions. These partitions are mapped to subdirectories. So, hello? Okay. I was thinking, yeah. So we have partitions, and to those of us that were familiar with partitions on tables, so partition is just what enables us to for a quick retrieval. So when you partition a table, it enables quick select or quick retrieval of the data set. So the system does not go around looking for unnecessary things. So that's why tables are advised to be partitioned for easy access, and I also support that. And you can see the buckets. We also have buckets too, so it's also a way of segmenting our data for easy access. Okay. Okay. So knowledge check. I think we see them answering our questions for us. Which of the following components of Hadoop provide SQL-like access? And that is Hive. So we can see how their questions looks like. So so um, so really understanding what MapReduce does, what HBase does, HDFS, the Hive. Then we know okay, it is the Hive that provides the SQL-like access to structured data and sophisticated big data analytics. MapReduce. Okay, so also interacting with the Hadoop ecosystem. So earlier we talked about the Hadoop ecosystem, talking about the pig Latin, the scoop, zookeeper. So let's see what all this guy does. Uh, pig was designed to make Hadoop more approachable and usable. So that's that. By a non-developer. Pig is interactive, script-based execution environment supporting Pig Latin, a language used to express data flow. So for guys that doesn't know about non-developers, Pig is a good to go guy that helps to approach to make Hadoop more approachable. So Pig execution environment. So when you're executing a Pig Latin script, it executes either on local or on the Hadoop. So he said all scripts for local running, said all scripts are run on single machine. Hadoop MapReduce and HDFS are not required. But on Hadoop environment, also called MapReduce mode, all scripts run on a given Hadoop cluster. So Pig can run without Hadoop environment, but as this course goes, it is that of the Hadoop environment that we'll get used to, whereby we run Pig on the Hadoop cluster. Pig program can be run in 3 different ways, all of them compatible with local and Hadoop mode. Yeah, so Pig can run in 3 different ways. So that Pig can run in 3 different ways. So the ways are what we call discrete, the grunt, and the embedded. So we can see that in our material, though we don't have it on the slide. So we see the scripting part, the grunt, and the embedded. So that's that. And also understanding that the Pig supports different operation. So we can, if we want to, for the sake of the exam, we might not be needing a deep understanding about Pig. It's just required for us to just know the basic. But if we want to know something in deep, we can just read further on Pig and Pig Latin, and we see that it's and trying to understand all the normal operation. So loading and storage, streaming data, filtering. So we can read more to understand how the syntax really looks like. Okay, so now scoop. Um, Scoop means SQL to Hadoop. So Scoop is a tool that offers capability to extract data from non-Hadoop data store. Please let us keep this in mind. I think I enjoy this part when we understand. So these are things we keep in mind to understand the environment. Scoop means SQL to Hadoop. So from non-Hadoop data store to Hadoop data store. So the tool we need is what we call Scoop. So we see capability to extract data from non-Hadoop data store transform the data into a form usable by Hadoop, and then load the data into HDFS. The process is called ETL. So Scoop is a tool from so if you want to load data from Oracle to HDFS, the tool needed is Scoop. So because it's going to pick data from non Hadoop environment to an Hadoop environment, and it supports the bulk import, direct data interaction, and data export. So it's a tool for ETL. It's an ETL tool. Okay, so also going to what they call the Zookeeper. So Zookeeper coordinates all the elements of so Zookeeper is the guy doing the coordination. So coordinate all elements of distributed application. There are a lot of distributed application. So what Zookeeper does is that, like when you talk about zoo, so let's try bring it to real life. So I'll talk about zoo. Zoo is just like when you have different animals, and the keeper is the guy that says, okay, lion, you stay in this cage, and tiger, you don't cross your boundary. So Zookeeper is also an application, is also a tool that coordinates elements of distributed application, so that they don't, every one of them don't go out of hand. It's the one that manages all distributed applications. Every application that needs to work on distributed on HDFS is the one that coordinates them. So that's Zookeeper for us. So we can see it like that. So we some features are process synchronization, configuration, and self-election. So please, 30 seconds. Okay. So those are the features of Zookeeper: process synchronization, configuration management. Zookeeper can be used to send configuration attributes to any of the nodes in the cluster. So please, let's keep these features in mind. Features of Zookeeper: process synchronization, configuration management, and self-election. So the next one is Flume. So what does Flume does? Flume is a distributed, reliable, and available system for efficient collecting, aggregating, and moving large amount of log of data from many different sources to a centralized data store. So to guys in the technical world, so we know of SSIS, right? So have you heard of SSIS before? Uh, Titilayo, have you heard of SSIS before? Hello.
Hi, Edward. I didn't get the questions. Have I heard of exercise before?
SSIS.
No, I've not.
Okay. So SSIS is a tool by Microsoft that does data migration, data extraction from different data sources into a centralized environment. So Flim is an example of the guy that does coordination from different data sources into a centralized data store. And we said, and I want to be sure you can still see my screen. Hello, Titi.
I can still see your screen, Edward.
Okay, fine. Thank you. So
Where are the others? I just two in the class, so what's happening?
Yeah, maybe the network threw them off.
Okay.
Yeah. Well, I'm sure maybe they will join back. Though the session is recorded and we can fall back to the record.
All right. No problem. Thank you.
So that's something about Film is uh, Film is a popular system for moving large quantity of streaming data into HDFS. So it does the work of ETL, and that's something we should keep in mind. So also we have OZ, which is an open source workflow and coordination service to manage data processing jobs for Apache Hadoop, and it is an extensible, scalable data-aware service to orchestrate dependence between jobs and running of Hadoop. So uh, they call OZE is based on work coordination. So we keep that in mind. And there's one question that I've seen is that OZE follows what they call a direct acyclic graph. So it says there's something like I said runs as a service in the cluster, and client submits workflow definitions for immediate execution. In OZ balance, a workflow is a direct acyclic graph. So I've seen a question that says, what is the workflow for OZ? We should keep in mind that it is a direct acyclic graph workflow. Okay. OZ has been designed to scale, and it can manage huge number of workflow. So okay, yeah. OZ Prelance, okay. Yeah, I think this is what I read. For us to keep in mind that it works with directed acyclic graph of workflow. I've seen that as a question before. So question, how does scoop works? So that's another check question. How does scoop work? What does scoop does for us? So and when I was explaining, I said scoop is like from SQL to Hadoop. So just data migration. You convert data from non-SQL, non-Hadoop base to Hadoop environment. Okay, what are some of the capability of Zookeeper? So these are another check questions. What are the capability of Zookeeper? We understand that Zookeeper is from process synchronization, configuration management, self-election. Those are the three um, capability of Zookeeper. And we have something like reliable messaging and queuing and sequential. So that's that. So these are things we keep in mind, and when we are going for the exam, we keep in mind. Okay. Um, question 10, page 10. Okay. Okay, points to remember. What are the points to remember? Like all we've said, and this is just like things we need to keep in mind. Please, Titi, when you're preparing for exam, please always note the points to remember. Those are one of the four of things to do.
Okay.
So the points to remember. So even sometimes if you can just go through, especially on the slides, on the,
Okay.
on the documents we have online. like on the resources on data science school, they are abridged version of what we have in the material, and I feel that they are more directly on point, and they tell us what they want us to know. So it is safer um, to also read through, go through the slide from data science school, even if you don't cover stuff on the handouts. When you walk through the slides, you can answer all your knowledge check questions, and you can see things to remember, and it's going to help get ready for the exam, and very easy and very simple. So all we've said, talking about the map and reduce part, the yet another resource negotiator. These are things they are expecting us to put in mind, and which um, questions from the exam will be coming out from. So we need to keep them in mind. So we can see this is how they summarized the Hadoop ecosystem, starting from peak, the scoop, the zookeeper, the flume, Ose, and the lights. So
Yes.
that's
Oh,
that. So you can easily see
then
some.
okay, Edward.
Yes.
When do we get access to this material on the DASCA website?
Okay. Currently, do you sign up on data science school?
I've not signed on yet, though an Excel was sent to me that I should fill my details on it, which I submitted yesterday. So I don't know if I'm to do it personally, or or Octave is registering us.
Okay. So they will do it. No. Okay. A mail will be sent to you. They will instruct you on how you go about it. But you are active on. Have you registered? Have you completed your registration on DASCA website?
No, we are not told to go to DASCA website yet. We made payments to Octave Analytics. Do you get? So I have a feeling maybe Octave Analytics is the one that will forward our payments to DASCA.
Okay. So very soon now, you will be set up on DASCA. So Octave is going to send you your credentials.
Okay.
So as soon as the process is done, so as soon as Octave set you up on the environment, then you can have access to all this material that I'm presenting with, and it is a good to go material on data science school,
Mm.
and it's like a presentation that you can just run through them to get the summary of even the entire page of
Mm.
maybe an entire work. So if you want to, if the material is like a bit boring, you can go through the corresponding slide on the data science school, and you have answers to all questions. You can see the same knowledge check questions that we have on the material is the same we have on the stuff. But have you gotten your DASCA package?
I have my DASCA textbooks already. Mm.
Okay. So that's fine.
So it's
Yes.
just access to the DASCA website now that we're waiting for.
Okay. Yeah. Okay, that's fine. Yeah. So we still continue with the DASCA material pending
All
the
right.
time. So yeah. So that's why we are here for class, but there's no
Okay.
problem. So I'm sure you get all necessary information soon.
All right. Thank you.
You're welcome. Okay. So finally, before we call it a day, just going through the final page, and the final page. Let's see. Okay, that is processing Hadoop map produce and yarn. Okay. Okay, this is just going a bit in depth into all I've been saying about map reviews and yen, but it is still the same, still the same big story um, of map reviews and yen. So whereby we have applications such as web crawling and query frequency were inadequate for the future as the number of web users were increasingly rapidly. So when you have say a big you are doing massive ETL, we can use MapReduce. So massive ETLs for say analyzing streams like say digital footprint of customers, web logs and the like. So um, that came in. So that is where MapReduce came in, and we can see uh, okay. So it said it's a new generic programming model known as MapReduce was designed. The name MapReduce comes from the practical and effective combination of two capability of existing functionality in computer language, map and reduce. Like what we've said. So this is just like a review of what we've done. So characteristics of MapReduce, like we've said, scheduling breaks jobs into individual tasks, synchronization, and code and data code location, fault and error handling. So those are features of MapReduce. So these are knowledge check and discuss how you can create a business analysis task and apply MapReduce concept to it. Okay, so we'll visit this later. So and how the MapReduce work. You can see how the MapReduce work. The MapReduce starts with a large amount of data, and you iterate over the data, break the data into bits, and you map it. Use the map function to extract something of interest and create an output of list. Organize the output list to optimize it for further processing. Use the reduce function to compute a set of results, produce the final result. Though we might not be asked this step, but we just need to keep it in mind. Though I'm not too sure will be required to explain the steps in MapReduce. So let's see what are we required. I'm looking for something. So okay, so we just need to understand how that works, but it's not so mandated for us to keep in mind as we move to the class or as we prepare for the exam. But it's good for the domain understanding of how it works. So like we've been saying, map reduce there's the mapping side and the reduce part, and the map reduce framework consists of the following nodes: the master nodes, and that's the job tracker, and the slave nodes, and that's the task tracker. So, so every job that is done, there's always a master node that tracks the job and the task. So the master node might sit on the name node, whereby the the slave node, the task tracker sits on corresponding data nodes. Okay, so we have this image on page 82, whereby we understand the process of a map reduce task. Starting from the computing task, we have the job tracker, the map task, we have map task tracker 1, tracker 2. So this is a case whereby we are using two systems to distribute the job. Data segment 1, data segment 2. So the same map work on different data, and each data segment generates their own output. So each output is reduced and to the corresponding map task, and we have our final output. So, and these are things we've been explaining, that when you have a job, the job is distributed into map and task, into different tasks, working on different segments, having different outputs, and being reduced. Please, I felt I need to do a knowledge check. Please, I want to ask question. Please, do you have any question? Am I is my pace? Though I believe lesson has taken us through this. I'm just doing a revision class, but I don't know if you have any question, because it's not so good when we keep reading and at least we don't understand. At least if we can understand 50% today, and when we read further we understand next 20%, and before the exam comes we are through with 100%. So please, do you have any question? Because I discover I'm saying a lot of things that might throw us off. Like, these things are too much for us to handle in just one day. Though it's a revision class, but we still need to manage the knowledge base. So, question. Okay. So, I assume we are fine with this. Assume we're fine. Okay. Um. Okay. Sorry for the slight break in transmission. Okay. So that is that. Just understanding how MapReduce work, and so when we go to page 84 of our material, you see the map example really works, how things really works out on MapReduce. So how jobs are being broken down, starting from the splitting, the mapping, the shuffling, the reducing. So that is that. So please, if you want to understand, have a grounded understanding about MapReduce, we should look into page 84 for proper understanding. And it is interesting. It is interesting when we understand how the MapReduce, how MapReduce really works. Okay. Um. Okay. Yes. 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 So this is the image. This is the image that shows us the process of a MapReduce. So my product broken. So this is a job, a text file, like this is a block of words that we want to do a word count on, and the word count is, we have mine, product, broken, angry, other word size. So we want to do a word count. So the first thing the system is going to do is split this into bits. So after splitting it, we are going to have a corresponding mapping, and we map to say how many mine do I have in each of the splits. The mapping is now going to collect like terms. So we are mapping count to each word. After mapping count to each word, the shuffling collects like terms. After collecting like terms, we now reduce it. So collecting like terms, we have maybe my appears in like say 100 times, and this is saying okay, my appears like 10 times, and it's not, the reduce function is just going to sum up all the counts together and say okay, my appears 10 times and reduce appeared 25 times, and we see the count of each word. So I'm very sure we are going to see a practical example of this in our practical class. I think that is one of the most interesting part of the map reduce practical class, and we can see how interesting it could be, and that's fine. So more about the map reduce function. It extracts characteristics of interest, present them in the KBP format, map gain a popularity with an article intelligence program called list processing. So, the list processing was what gave the MapReduce job the popularity it ends today. And also MapReduce works with Hadoop and natively uses the same language. So functions can be written in Java because Hadoop is written in Java, and also MapReduce can be written in R. So we see that as we move on in the course of this lecture. MapReduce framework uses key value pairs as input and output. So so it's just like key and value. So to each key, there's a corresponding value to it. That's what we understand about key value pair. So when we have a key, let's say a key is like a name. Say, okay, let's go back. So mine is like a key, and 10 is the corresponding value. So that's what we call the key value pair. So the reduce function receives key value list as an input and returns another key value pair list as an output. Like what I said, you have the key and the corresponding value. Okay, and so that is that. We have an example. Said an example of a MapReduce program, and that is what we've explained in a nutshell. Okay. Okay, fine. Yeah, knowledge check over. Okay, that's fine. So cool. So I would like us to go into our knowledge check for the rest of this class. Knowledge check. So I only have Titilayo here. There's no problem. Let's see. So the knowledge check one. Titi, are you with me so that we can answer the knowledge check before we call it a day? Or if there's any knowledge check you're unable to find answer to, so that we can reason it together and provide answer to that. I think that would be a faster way to solve it.
Hello.
Hi.
Okay, I guess my earpiece isn't working. As I've been speaking, but my earpiece wasn't working. I had to remove it from the laptop now.
Okay.
I'm with you.
Okay, so we just want to go through the knowledge check. So which of have you tried attempt the knowledge check and see which one do we need clarity on? So we just want to see the knowledge check because that's the most easier way for us to prepare for the exam. So which of the knowledge check do we need clarity on before we call it a day?
Okay, like what we even have in the textbook, like the last time I had lectures, I discussed with Blessing that
Okay.
was there a place we could get the answers to what we have in the knowledge check? Well, he said there was no answer, that the answer was actually in the write-up. But you know, for we that were just starting, it might be a bit technical for us to know which of the answers. I know the way the questions are set, the questions are very close to each other. So you need someone with experience and well-rounded knowledge you get to be able to know the correct answers to these things.
Okay.
So that's one of
Okay.
the challenges I have with the knowledge check. How do I even know what I'm picking is actually the correct thing or not? And that's why
Okay.
I asked him in yesterday's class if we are going to discuss this, because there's a power with discussing most of this topic. It also helps you gain knowledge.
Okay. All right. Okay, I get you. So that's fine. So that's why we're opening this session so that
Okay.
we can discuss all the knowledge checks. So
Okay.
that we also take notes of the knowledge check and we keep it in mind.
All right.
So when we answer it together, so we're going to start. So we're going to. I think we still have some 20 minutes thereabouts. So knowledge check one. So are you with your material page 7?
Yes, I'm with it.
Okay. A, a manufacturing company needs to improve its sales in the coming year, but does not know how. The company has sales transaction and customer database. How do you think the company can make use of the information? So do you have an idea of what the question is asking?
Yes, the answer should be A. The company can make use of their sales data to study the customer behavior and also to target them accordingly, because that is one of the importance of the big data, to be able to study customer behavior and be able to target sales or channel your product towards them based on their behaviors.
Okay, that is very that's the correct answer. So as we understand that one of the reasons why we do big data analysis is especially when you're doing um, anything that do with transaction, we want to understand the customer behavior and being able to target them. So see, one thing is that when you now check other options, it's not that the other options are out of scope. The company can send coupons to all customer. The company cannot do anything with data. The company should launch a new product. So that's one beautiful thing about DASCA. Some some of the objective questions are commonsensical that when this answer looks right. So that is the right answer. A is the
All
right
right.
answer. So fine. Knowledge check 2, page 8.
Page 8, 1 minute. The data-driven approach to decision-making is not confined to only collecting data, but also to how the collected data is being used in making crucial decisions. The approach here is based mainly on what I said, data and its analysis,
Okay, so why do you pick data and its analysis?
because they're talking about data-driven approach in decision-making. First and foremost, you have to collect data, and it is when you analyze the data, you are able to make decisions from it. You are able to make sense from whatever data you collect to be able to make crucial decisions.
Okay, so yeah, fine. So just find what you said, but also to how collect data is being used in making crucial decision. So
Okay.
in making crucial decision, there's a need for what they call the data analysis. So which is the correct option you pick, data and its analysis. So it's not about experience because customer behavior changes, data changes. So you can't say, okay,
Yeah.
based on my experience, let me just work on this. Intuition. So we can use intuition to say, oh, I think this should be right. No.
Okay.
And data utilization. So how do you talk about data utilization without analysis? Are you getting me?
Yes.
So, so data and its analysis is something that helps us in making crucial decisions. So that's
Okay.
fine. So question A is the answer. So one thing I'm going
Okay.
to do is that, so the next time we are going to review this class, maybe if anybody asks questions, so you are going to be the team lead to provide answers. So you are not going to be the class captain.
Ah, no,
So
I'm not class captain. No. What do I know? I beg go.
so that, so that is what.
I'm already thinking of running away from the class even.
Uh, so that's why you won't run away because
Yeah.
now. So if
Odila already.
uh, as I'm taking you now, so in case it's just pending me that I won't be, maybe I might not have opportunity to take you guys again. So I'm expecting that when anybody asks questions, you tell Blessing, Blessing, I know the answer. Let me teach them because when we teach, we understand better. So don't run though. So don't run from sharing knowledge. If I think you don't know, or at least you are still better than people that are not in class. So
Okay.
11,
Okay, page 11.
yeah.
Okay. What's this question about now? Okay, APC is a retailer organization that conducts its business through e-commerce. The organization offers customized online shopping experience to its customers with an attractive and responsive web page user interface. Now the company wants to collect the data with customers' activities on the internet. What can be the best source for such data?
Okay.
I'm coming on APC. I guess it should be all of the above.
So why do you pick all of the above?
Okay, number one, their transactional database will tell you about what the customer is transacting on the e-commerce website. Social media will tell you the customer's behavior and what they're saying about your products on social media. And then weblogs of customers also, I guess it will give you an idea of what the customer behavior or customer preference is. And that will help you to be able to target the customer. Like, for example, now if you go on Jumia and you click on a product, it will begin to tell you that other customers viewed this item. And then there are times that you find yourself also clicking on those items, and if possible, even buying the items yourself. That's why I
Okay.
feel it should be all of the above.
Okay.
Not so sure, Sha, but
Yeah. Okay. Now let's argue it. So let's see how logical it is. So one thing I do about is that, okay, let's think it logically. Now the company wants to collect data about customers' activity on the internet. So now the moment I saw on the internet, I understand that it is not only on their website.
okay.
So assuming it's on their web page alone, now I would have just say, okay, the weblog of customers on their web page should do. But so far it is on the internet, so that means they need some extra data sources
Mm,
to understand their customers' activity.
yeah.
So they can get it from the customer weblog. The customer weblog will tell them how many minutes does this customer spend on my website.
Mm,
After spending X amount, did he later buy anything?
okay.
So now social media, is there any social influencers affecting our customer behavior?
Mm,
So it will be good to say all of the above because I would have picked maybe transaction database or weblog of customers, but so far we don't have A and B. Then A, B, C, all of the above will be the best option.
all right.
All right.
So I'm correct, right?
You are.
Okay, thank you. Sorry, my earpiece is so bad. I'm just training my ear to really hear you. I'm trying to change my earpiece now. Just give me 30 seconds.
All right.
Okay, can you hear me, please?
I can hear you.
Okay, thank you. I had to change my earpiece. Okay, thank you for that clarification and better understanding.
Page 12.
Okay, it says, what do you think could be the biggest challenge for the production or operations unit of an organization? A, determining the data to be used for making business decisions, determining the best big data technology to be used, secure initiatives for unauthorized access, determining the best way to present big data findings to enable decision making. 1 minute.
Okay.
I guess it's A.
Okay.
And why I'm choosing A is because you need to know the data that you need to work with before you even know what technology to apply to it.
Okay.
So I guess the data being generated or the source of the data might be one of the biggest challenges. And when you know the data, we have lots of technology around that will help you know if you should use big data, if you should use other analytics methods to analyze the data.
Okay. Okay. Fine. Currently, I want to explain something. So currently, I have opportunity to work on a project, and the project
Okay.
is on all these oil company, and we need to do some predictive modeling for them. So the challenge is how do you get data points?
Okay.
So that's the this is a real life experience. Like the challenge is, are they having the data? Talk less of going into the technology. So in real life, I'm agreeing with you that the time the data to be used for making business decisions, because this is operation and production. Though, especially for operations, how do I take timestamp? How do I take timestamp of when my machine is going down, or when my machine is failing? How do we collect that data? So to collect data for these guys, for the production guys, they need to embed what they call the IoT devices,
Okay.
and which is the challenge for them. So if a machine is failing, how do we know? Most of the time they don't know. Most of the time they
Okay.
use a secondary data to infer that, okay, it seems we start noticing that maybe the size of the bread, maybe it's a bread manufacturing company. I say, okay, we discover that the weight of, because the machine is going faulty, let's discover that the weight of the size of the bread is reducing, or probably it is overscaling it. So they
Okay.
don't know directly, so they only infer. So getting the data is a big challenge for them. So you're right.
Okay. Okay. Maybe
So
I should just go and write this exam. Oh. I should conquer my fear.
no,
You said?
I said you think you don't know, Abby.
I think I don't know. If I'm afraid, I was still thinking this morning if I should continue with the program or not, because it's beginning to look very technical, sound very technical. I actually have a bit of background in the use of Power BI and Excel for data analysis. So I was
Okay.
actually looking at when I saw R as part of the syllabus for this course. That's why I actually registered, just to gain the knowledge of how to use R. To move from just being a data analyst to maybe like data scientist and stuff like that. But when I was beginning to hear all these technical terms about computer, I was confused. So I was just asking myself this morning that am I sure I will do this course again?
Okay, so that's the, I think that's the challenge of that. Those are one of the hurdles we face when we are coming to a new space. I think it happens to every one of us, where I feel like, wow, do I need to leave my comfort zone? Let me stay in the domain of what I know. So, but I can bet it with you, by the time you just press, you just need to press a bit. But when by the time you understand the concept, Lobaton, it's got that it's not a big deal. It's just everything you are saying is just grammar. So don't be intimidated by our big grammar and I feel like just take your time. It's not that some of these things are commonsensical. Oh yeah, let's go. You see that you can even, like you said, you are ready for the exam. Just go and schedule it.
I wish you.
Okay, page 14.
Page 14. Okay. With the enhancement in technology, companies are using different ways for marketing their products and services. The new sensors are being used with new marketing campaigns, and this results in new type of data and information. Which element of big data is being discussed here? Just 1 minute. With the enhancement in marketing campaigns and this. I guess they're talking about the variety of data that we have, the different types of data that we have.
Yes. So they said the new sensors are being used with new marketing campaigns, and this results in a new type of data and information. Which element of big data is being discussed? So let's recall our element of big data, the volume, the velocity, and the variety. So the volume is talking about the size. So the data set is now very large. The velocity is talking about the rate at which data is coming in, and the variety is talking about different dimensions.
Yeah.
So now they are not saying when you are collecting data from sensors for marketing, which of the element of big data will the data generated satisfy? So that's the question.
I'm coming if you're collecting data from
Sensor. So the new sensors are being used with new marketing campaigns, and this results in a new type of data and information. So which element of big data? So when you're collecting data from sensors now, so what do you see will be, what do you see about sensor? How do you see that sensors will be collecting data? And what do you, is it going to be voluminous? Is it going
the
to
volume and the velocity.
Yes. So the volume and the velocity. So it's going to be because sensors will be collecting data per seconds or sometimes per minute. So the volume will be high, and the velocity, the rate, it can be per minute, and the data will be coming in. So the volume and the velocity is what the data, the type of data that will come. It's not in variety because it is just marketing data. I get it. So it is volume. The volume will be very much with time, and the velocity, especially velocity, it will be high. So volume and velocity. So you are ready for the exam. No, see, so one thing about DASCA, like I told you, DASCA can be intimidating, especially when you do some of the exam, when you do some pre-exam. I told you yesterday, a day before my exam, they told me, Edward, you are not ready for this exam. I was scared, like after reading everything, like But my guy said, Edward, a man can only die once.
All right.
And when I wrote the exam, it's commonsensical. You have enough time. You have like 2 hours for maybe 80 questions. So you have enough time to review, to think logically, and like, I've read this thing before. Remove it. You can think it out logically. You just need to understand the concept. Like, we understand, okay, what is volume? We understand what is variety. We understand what is velocity. Then we now use that on the question, like, okay, it doesn't look like volume. It should look like velocity. Now, okay, it looks like one. So, and you can just pick out the odd questions, odd options, and get your answer. So that's DASCA for you. So page 16.
16. Okay, 1 minute. Mm. Okay. You are the marketing head of an organization. You plan to increase your market outreach by converting prospective customers to actual customers. Which of the following analysis approaches would you consider to be the best to adopt?
Okay.
This will be their behavioral analytics.
Okay, you plan to increase market reserve by converting prospective customers to actual customers. Which following analysis approach you consider for the best? Okay, actual
But it's
customer.
actually confusing, Sha.
Oh yeah, let's remove the odd ones out. It cannot be data interpretation.
Yes.
It is not data collection,
Mm,
and it is not data visualization.
okay. Because, okay, I get now. Because data collection, data interpretation, data visualization is actually embedded in behavioral analytics. It covers up
Yeah.
the three other ones.
Yes.
Okay.
That's
So
that's
I'm, I'm,
that's the,
I'm beginning to understand their patterns.
that's the real pattern of DASCA, and that's how their question comes, whereby you can think it through. So that's fine. Page
Okay.
8.
Page, what now are we?
Page
18.
18.
18. Okay. Sam is seeking a career as a data analyst. Which of this is a key responsibility of a data analyst? A, determine what data means and recommend ways to search the data. B, specialize in collecting data from different sources, organizing it in suitable format and making analysis. C, design, create, manage, and interpret large data sets to achieve business goals rather. Develop codes and images to automate data reports. Okay, 1 minute. Where's the collecting data from? I would say it's hovering between B and C, but I'm going to choose B. Reason being that as a data analyst, it's not only large data sets that you'll be working with, because C is specifically restricting this to large data sets. I don't know if I'm correct. So I will be
Okay.
sticking with B because it specializes in collecting data from different sources, organizing it in suitable formats, and making analysis.
You are 100% correct. TT, you are
Okay.
ready for the exam.
Are you sure?
So that means that if you can take your time just to read through, you
uh,
understand. So let me challenge you for one thing. Go to modules that you've not treated.
yes.
Go and attempt the knowledge check. So when you get to the
Okay.
knowledge check and you can't find it, go into material and look for the answer. With
Okay.
that is, I can tell you, with that, it's going to prepare you 70% for the exam.
Okay.
Even before reading the entire book, start with the knowledge check and go back to the material. So that will make the knowledge stick better. And that was what I did when time was against me.
Okay.
Are you getting me? So if you
No.
do that, it's going to speed up the rate at which you cover this material. So when you cover the material from the knowledge check view, it speed up your rate at least by 40%. So that is what I would recommend moving forward.
Okay.
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 So
Now,
that
wait, I just want to get clarification. So instead of having to read through everything, I should just be going to the knowledge check and then work like I'm working from the answer to the question kind of way of reading.
yes. So
Okay.
that will push you. What happened then was, so when I read the question and I discover I don't get the answer, so it will force me to go and start reading from the beginning. Do you know you are looking for the answer now
Mm.
and you don't know where the answer is? So, but that will create curiosity to understand and learn and to grasp. So it is building that curiosity in your mind that okay, I'm looking for this. So it, at the end of the day, and one thing about DASCA is that the answer to the question might be on the last page. So at the end of
Yeah.
the day, you start reading from the first page down to the last page. You will have
Yeah.
finished the entire book, and because you will be trying to keep notes of what you are reading, it's going to
Yeah.
help you start them better.
Okay.
Because you are having a quest that I'm looking for something. But when you are just reading that I'm not looking for anything, let me just read to know. But when you're reading from questions to answer, it creates
Mm.
that curiosity and enables you to read something and have the consciousness to remember them.
Okay.
Yeah, it's really helps.
All right. Thank you so much. I guess I'm
No,
going to use you as my personal mentor and tutor. Hope it's free, Sha.
no,
All right. Can I have your phone number, please?
okay. Okay, my phone number is okay, I'm gonna okay, let me call it.
Okay.
Okay, 070
All right.
55
55
165
165
729.
729. All right. Thank you so much. I'll
Okay,
chat you on WhatsApp.
all right.
Yeah, thanks. So are we
Okay.
still after this class? Do we still have another class?
With me,
As in, are we closing for the year with this lecture now, or there's still another class? Because Blessing mentioned about closing for the year.
yeah, so there's tendency that we are closing for the year.
Okay.
So we'll be starting
Okay.
January, first week in January, hopefully.
Oh, okay.
So, but before that time, you can chat me up.
Okay.
You can keep reading, such that by the time we come back, you will have moved at least 2 modules, like say maybe 8 sessions um beyond the class. So
Okay.
just
I
read.
really want access to the DASCA module. It's more coincides.
You are reading what?
I say I would really love to have access to the DASCA material online. It's more summarized than what we have in the book. When you see the book, you become afraid.
Okay, okay, I get you. I get you. So, okay, I
Oh,
will. So, I'm very sure they are working on it, and your access will be created soon, and
yeah.
it will be forwarded to you.
Then I don't know. Maybe you guys can talk to DASCA for us. They should come up with past questions for us now to really help.
Okay, okay,
Then also, please, for me that I'm taking is it SBDA I'm taking now?
okay.
Yes, the SBDA. The questions, are they going to be more technical kind of compared to the engineering guys? Maybe like, do I really need to know so much about all this virtualization, all this parallel computing, cloud computing and co like that? Or I should just focus more on the analytical aspect of it, maybe like the R and stuff like that, all this data node, name node. It's as if they're just speaking above my head.
Okay. So, what you just need to do in that is that you just need to. Though there are some questions that will be coming, there are
Okay.
some questions that will be coming from them. So you just
Mm,
need to see when by the time you attempted them by knowledge check questions,
mm,
you will have at least an idea of what will come out in the exam, and at least
okay.
you'll be ready for things like that. It is not too abstract when it comes to their question.
Okay. Okay.
Okay,
Mm. Okay, no problem. I will keep reading. I will try and read up this holiday period. If I have any challenges, I'll just put calls across to you.
no
I'll
wala,
chat with you. Mm.
no problem. So okay, so one thing assignment I will give you. So this assignment is personally for you because you are the one that stayed to the end. So the assignment
Okay.
is this: all the other test questions, the knowledge check questions, please answer
Yes.
them, chat me up and send your answer. So and I will send you my opinion on them.
Okay. For which chapters now?
So
What
where we
section?
So I think we stopped at let me
Session
see.
5, right?
So we stopped at session 1. So you do session 2 to section
Okay.
5. So you send
Okay.
so the only there are some questions that they are narrative. So if they are narrative, you might not need to send it, or else you send a voice note if it is
Okay.
narrative. And if it
Okay.
is optional, you can just send option 1 question knowledge check 2 session 1. So,
Okay.
okay, session 2 knowledge check 1, this is the answer. Session 2 knowledge check 2, this is the answer. So once you send out to me, I'll give a feedback, and I will tell you what I think about it.
Oh, okay. Okay. Um, do I have a little time for this, or you want me to submit immediately?
No, you have a little time for this.
Okay.
So
And
I'm afraid.
because end of the year for me in the office is I have to balance books and stuff like that. But just give me time. Definitely before the end of the year, by the grace of God, I'll respond to this.
Okay, though I'm expecting.
If I can't do it at once, I'll do it session by session.
Okay, so can we just put a time frame and say, okay, before next week you should have completed the entire session. So if it is one session you can do in one day, send it to me. So before next week
Okay.
Friday, you have completed the entire session.
And don't let me complete the entire session in 1 week. Because by the time I get to this Hadoop and the HDFS and co, I will need
If
to slow down, read very well,
oh
understand,
yeah,
digest.
oh yeah, okay, but I'm very sure 5 days will be okay for the remaining 4 sessions. Just need to
Okay,
spend.
let me challenge myself. I will not say no. Let's start. And
Oh
wherever
yeah,
it takes us to.
okay, no problem.
Yes, I will start
Thank
it.
you very much for staying to the end of the class.
You said?
I said thank you very much for staying to the end of the class.
No, all thanks to God though. Yeah,
All right, ma'am. So
thank
have
you.
a fruitful weekend and enjoy the rest of the week.
And you too. Thank you so much. I really appreciate your time.
Yes. Bye.
Bye.